Hello all, this is Shambhu Rawal. Today I'm going to share my project, the effectiveness of COVID vaccine towards the new COVID cases and deaths in US state. This is the final presentation for Data 670 Data Analytics UMGC course spring semester. My main agendas for this slides are for this presentation is project scope, data set description, high level diagram, data presentation, cleansing, transformation, data visualization, predictive models, final results. COVID-19 is a type of virus called SARS-CoV-2. Anyone can get COVID and may become seriously ill or die. It transmits easily from person to person, and the virus spreads massively. Older people and people living with medical condition are most affected and become serious by COVID. The COVID induced recession in the world. People lost their lives and jobs. The COVID affected every sector in the world. Different people may have different symptoms such as fever, chills, fatigue, headache, short throat, coughs, etc. Mainly, the COVID affect the lungs and respiratory system. The World Health Organization recognized five different COVID variants as a variants of concerns, which we can see in the slide. My main objective of the project was the project to identify the best worst US state based on vaccine effectiveness, to identify the best worst US state based on unemployment rate, and then last one is the it analyze the best worst US state based on COVID new cases and deaths. The KPIs. The first KPIs are the number of COVID cases before and after COVID vaccine. The new case will drop by June 2022 in US. Another one, the second indicator was the death rate will drop by June 2022, and the third indicator was the unemployment rate will drop to the normal rate that was before COVID, and the last one it will predict a decrease in new cases and deaths. It will also predict the drop in unemployment rate. That was my KPIs. Project milestone, how it came like how I prepared this report. This is what I'm going to share here. Identify the best uh, identify the data set based on the study objective, analyze this project scope, identify the tables, variables, exploratory analysis, predict model analysis, enhance the models to improve accuracy, and complete the final report. This is the high level diagram. The high level diagram shows three different data sets: vaccine data, COVID cases and deaths. Vaccine data, the three different data sets are used here. The COVID case and deaths, and then unemployment rate data. Tableau prep has been used for the ETL process, data preparation, data cleansing, and blending process. The SaaS enterprises, and the Tableau has been used for visualizations and predictive model analysis. Primary dataset, the US state and COVID vaccine data was the primary dataset, which had 16 variables, one text, one date, and then 14 numeric. 25,252 rows of the data were there in the primary dataset. Then second dataset, I used the COVID-19 case and deaths by state over time as a secondary dataset. It had 15 variables, two dates, three text categorical, and 10 numeric variables, which includes date 44,700 rows of records. Then the last data set used as a US state unemployment data. For the data visualizations, I prepared few charts in the Tableau desktop. The column bar charts, which displays the difference between state values, and then I prepared the line charts that is for time series, shows the historical trends. I also prepared the map chart where the states are located. Is there a trend on specific areas? I also prepared tree map chart and bubble chart. Tableau is one of the best visualization tool. I'm using Tableau I used Tableau to display the charts graphs for my project. These visuals helped to identify data patterns, trends, and gaps by human nature. People understand and get more insights through the visual. I created different interactive dashboards where I filtered by state and by date. I also created the parameter to show top and bottom states. This is the Tableau dashboards. The In this tableau dashboard, I have four different interactive charts. I have a filter in state name, and here we can see these in top of the charts. The first top left chart belongs to total COVID cases. The data has been sorted by state. The highest total cases are on the top, and the lowest total cases are in the bottom of the bar chart. California has the highest 1,545.6 million total cases, where Wyoming has the lowest total cases of 5 million. The top right chart shows the new cases by state. The COVID new cases are on one of the targets variable of my project. In this chart, the new cases are sorted in descending order by state. All the values are formatted to million. California is the worst state in COVID new cases. California had 8 million new cases. Texas had 5.9, and Florida had 5.6 new cases. Wyoming had zero point 0.0, Vermont had zero point 0.1 million, and then Washington DC had zero point 0.1 million new cases. And the line chart below, the new cases are on y-axis and the period is on x-axis. It shows COVID new cases from March 2020 to January 2022. In March 2020, there were zero point 0.2 million total new cases, and in January 2022, there were 18.3 million total new cases. January 2022 is the worst period where the new cases were highest compared to other periods. At the beginning of the COVID pandemic, COVID new cases were zero point 0.2 million. In March 2022, the COVID vaccine was introduced in December 2020, January 2021 in the US. After the COVID vaccine, we can see the drop in COVID cases. It clearly explains the COVID vaccine's positive effectiveness towards the COVID new cases. The bottom right chart includes the parameter. It displays the top 5 states by COVID new cases. I have set of 20 in parameter, so we can see up to 20 top states in this chart. California has had 8 million, Texas had 5.9 million, Florida had 5.6 million, New York had 4.8 million, and Illinois had 2.8 million total new COVID cases. I prepared the in similar setup the another tableau dashboard that shows total deaths by state, new COVID deaths by state, new deaths time series line chart, and then top states by COVID new deaths. It has similar filters, state name, and the year. The total deaths has been sorted from highest to lowest in US state. 27.6 million total people died in New York. 24.6 million people died in Texas, and so on. Wyoming has the lowest death, that is zero point 0.1 million. Vermont is the second lowest, and then Alcatraz is the third lowest state and the lowest death. The top right chart displays new deaths by state. The chart displays 80k new deaths in California, 78k in Texas, 66k in Florida, and so on. 0.5k new deaths in Vermont, 0.9k new deaths in Alaska, and 1.2 new deaths in Hawaii. Vermont, Alaska, and the bottom left chart displays the new deaths in line. It shows the historical trend of new deaths. The x-axis displays the number of new deaths, and y-axis displays the period. It captures all the new deaths from March 2020 to January 2022. In January 2021, in 2021 January, 97k people died in the US. Another dashboard shows chart shows COVID vaccine status in US state. The top left bar chart displays the total number of people vaccinated by state, and then the top right bar chart displays the number of people that fully vaccinated by state, and then bottom line chart shows the number of people fully vaccinated. The another chart displays the unimplemented status by state. Top 5 and bottom 5 states are displayed in the chart. Before the COVID or beginning of the COVID pandemic, it was average 3.9 unimplemented in the March 2022 in the US. Because of COVID, it went all the way up to 13.7 average in April 2020. The unimplemented has improved gradually after that month. California was the first state that had highest new cases, new deaths, and highest unemployment rate. The chart displays the new cases, new deaths, and unemployment rate in on dashboard. The map chart shows the new cases highest and lowest with the color. All the line charts displays the historical trends after the COVID vaccine started in December 2020, January 2021. The new deaths, new cases, and unemployment rate has been decreased due to the new variant in January 2022. There was a hike again. Tree map chart displays the new cases. The bigger and the darker the size has had higher the new cases, and the smaller and brighter the size had lower the new cases. California, Texas, and New York are at the top states. The right bubble chart displays new deaths by state. The big bubble shows the top, and the small bubble shows the smallest state based on COVID new cases. Predictive modeling. The predictive model used historical data, machine learning methods, and statistical algorithms to predict the outcome. It helps to identify and analyze what has performed, what has happened, and what will happen. The predictive model will help identify whether the COVID vaccine helped to reduce COVID new cases, COVID new deaths, and unemployment rates or not. Linear regression model, where I had used four different variables, forward variables, three different variables, forward variable, stepwise variable, and backward variable. The linear regression helps to get the line that fits the scatter that data point. The line will help to predict values based on independent variables. This model calculates the best fitting line that minimizes squared error or distance. Gradient boosting model. The another model I'm going to analyze. I analyzed gradient boosting. The model resamples the data set many times and uses the weight data to get the results. The last model I used, the HP forest, that used to make a final decision from the many decision trees. Multiple decision trees were built on the training dataset, and the final decision tree created based on the majority vote of the other decision trees. The diagram shows how I have used the nodes to build and compare the model. It splitted the data into 70% of training and 30% to test dataset with showed partition node. All three above models will be all three above models were compared with the help of model comparison node. The average squared error, maximum absolute error, the sum of squared errors were analyzed in the analysis. Here are the results of the predictive modeling. The linear regression model helps to identify or estimate the relationship between the independent and independent variable and the dependent variable. The model finds the baseline linear between the predictor and response variable. The linear regression model helps to identify cause and effect and the relationship between the variables. Linear regression is one of the best forecasting models. The model helps to determine the strength of independent variables on the target variable. The model also good for understanding the forecast effect. It fits the straight line, which helps to minimize the difference between the actual and predicted value. The model is simple and uses a mathematical formula to predict the value. The gradient boosting model is a method to create predictive models for both classification and regression. The model trains many model where it creates many decision trees options and helps to get the best predictive model. The ensemble weak prediction model was created as a decision tree model. The gradient boosting model includes the addictive model, weak learners, and loss functions. In the model, learners had equal weights, and the weaker learner modified and become a better model. In the model, it resamples the data set several times, uses their weight data to return the results, and selects the best model. The HV4S predictive model contains different decision trees. It assigns the record to a single leaf in each decision tree. This ensemble model builds different decision trees on the training dataset. The model shortages and identify the best feature among others. The above forces improves tree diversity. The model provides here are the results of predictive model. Per the SAS enterprise manner, the gradient boosting model is the champion model. The average squared error for the gradient boosting had 3.29. Linear regression backward model had 5.18. Linear regression forward had 5.18. Linear regression stepwise had 5.18, and HP forest had 6.38 in the trend dataset. The maximum absolute error for the trend dataset is as follows. Gradient boosting had 12.59, linear regression backward 16.21, linear regression forward 16.21, linear regression stepwise 16.21, and HP Forest had 19.17. Similarly, the root average squared error was following gradient boosting 1.81, linear regression backward 2.27, linear regression forward 2.27, linear regression stepwise 2.27, and HP Forest had 2.53. The sum of squared error of the trend data set was following gradient boosting to 2594.78, linear regression, linear backward, stepwise, and forward had same value of 4079.65, and the H Forest had 5000 to 8.54. The lower the average squared error, maximum absolute error, root average squared error, and the sum of squared error, better the model. Thus, gradient boosting model was the champion model among these five models. I also created Rapid Miner Studio uh, mm, and analyze the model. The powerful data mining tool called Rapid Miner Studio enables data mining, model deployment, and model operations. It is an integrated environment for data preparation, machine deep learning, text analysis, and predictive analysis. I've chosen all three variables: COVID new cases, COVID new deaths, and unemployment rate as a target variable. The generalized linear model, deep learning, decision tree, random forest, gradient boosted trees, and support vector machines are built in the Rapid Miner tool. Please, we can see the results in the below table. I'll share in the next slide. It displays the root mean square error, absolute error, relative error, squared error, and correlation for all the models. Per the rapid miner tool, the result also shown the gradient boosting trees model is the class champion model. Gradient boosting model had the lowest rate on the following compared to other models: 1.96 in root mean squared error, 1.395 in the absolute error, 18.2 in the relative error, and 3.9349 squared error. The gradient boosting model had the highest correlation of 0.827 compared to other models. Hence, the gradient boosting model is the champion model. The best model of the root mean squared error is between zero point 0.2 and zero point 0.5, and that means the model can relatively predict the data accuracy. In the analysis, the gradient boosted trees had the lowest root mean square error of 1.96, which is the standard deviation of the residuals prediction errors. It shows the difference between the predicted value and the actual value. A good model should have an absolute error that is close to zero. Zero is the best value. The gradient boosted model had 1.395 absolute error, which is the champion among others. The relative error is the ratio of the absolute error of the measurement to the accepted measurement. The perfect relative value is 0. Gradient had 18.2 and its lowest compared to others. The perfect squared error value was is 0. Gradient has 3.94, which is champion. It means the prediction did not match exactly as expected. The correlation describes the degree to which two variables move in coordination with one another. The correlation coefficients values range between -1 to +1. Gradient boosted had highest correlation with 0.827, and compared to others it is the champion. These were the indicators. KPIs. The gradient boosted model is the champion model. It has the lowest root mean squared error, absolute error, relative error, and squared error compared to others. The model found the highest correlation between the dependent and independent variables. All the KPIs are analyzed. We can see the number of new COVID cases has been dropped. The new deaths and rates has been dropped. The unemployment rate has been dropped. We saw that the hike in COVID-19 new cases because of the COVID in 2000, we saw the hike in 2022 January. The new COVID cases because the COVID new variants Omicron came, but the death rate was dropping since the absolute error, relative error, and squared error are not far from the zero value. The model is predicted closely. Main lesson learned. In my view, the previously I had used the Excel analysis to identify the outliers. I missed some of the outliers. Those I learned to depth analysis, exploratory analysis, tableau desktop, or some of the other tool. I created some charts and identify the outliers. KPIs, identifying KPIs was the challenge for me. Then there are multiple target variables. Like I had three different target variables. That was challenging for me. And then from the like, I need to create everything from one data source. And then it had the issue of data gaps because the size of population. We can see the women has the very small population, lowest, and then California is the top. And here are the references. That's all from for my presentation. Thank you.